Alex Diem is doing a PhD about mechanisms to do with Alzheimer's. So how would you characterise your research?
So I'm mainly interested in the lymphatic system of the brain because we know a great deal about the lymphatic system in the rest of the body. But in the brain, we don't see these lymphatic vessels that you would have elsewhere. So we only have our arteries and the brain mass. So we're trying to figure out how the lymphatic system works and how it fails and how that causes Alzheimer's disease.
What precisely are you doing?
I simulate the flow of lymphatic fluid through the walls of cerebral arteries, and I do this using a multi-scale modeling approach, which uses a mathematical analytical model for the actual fluid movement and numerical models for the artery walls.
And what's the significance of complexity and complexity simulation in your work?
So it's a very new approach to use actual simulations to also devise experiments following that, because people usually do experiments, then they devise some explanation, and then they devise new experiments and further their hypothesis like this. But what we're doing now is we're aiding the experiment development process using simulations.
And what do you think will be the impact of this approach on science generally?
So the impact would hopefully be that more people start using this approach of utilizing simulations and also mathematical modeling, because at the moment mathematics or engineering and medicine are relatively separate fields, whereas it would be very beneficial if we could move them closer together and make them more interdisciplinary.
Alex, thank you very much.
Thank you.